We are working on the Minesweeper project from the YByte Python curriculum available at www.ybyte.in. In fact, we are almost at the end of the game. The only thing we need to now build is, the mechanism to determine, let's say, if the player has won. Now, in order to illustrate my point as to what we are trying to build here, I have just played this game, which is almost at the end. And how do I know it's almost at the end? Well, you notice I know this is a mine. I know this is a mine. These two are mines because, one here, one here. These two are mines because of the two here. I know that this is a mine. I know these three are mines because notice there's a four over here. So these four are all mines. And obviously this is a mine because it's surrounded by all ones over here. Now I'm left with just two squares. I know this is a mine because of the one here. I know this is not a mine. Now the moment I click on this square, I expect the game to get over, and indeed that's what happens. So basically, once the game is over, I want to sort of congratulate my player. Of course everything remains disabled. That is okay. It must get disabled, but I want to now highlight all the, let's say, mines once again to sort of recorroborate to confirm that, look, you did everything right. And here's the situation. I want to put a message here, something like, let's say, you won. Now, the logic here is actually very simple. You remember that the moment I click on a button, whether I, let's say, click on a numbered button or I click on a zero, let's say, a zero neighbor button, the moment the button has been clicked, in fact, it gets disabled. So in case of numbered button, we immediately disable the button. In case of, let's say, a button of this sort, which doesn't have neighbors, recursion runs, it kind of spreads through the entire, let's say, field. Whatever button gets opened up that way is also disabled. Now, what does it mean? Well, I can keep counting how many buttons have been disabled in a situation where I'm finding, let's say, mines, and I'm still going on. The moment I am left with exactly number of squares minus the number of mines buttons as, let's say, disabled, then I know the game is over. Because remember, in my game, the mine buttons are not being disabled while the game is going on. When I, for example, click this one, it's only after that that I disabled the mine buttons, which has happened now, right? So basically, if I check, let's say for winner, after every, let's say, every time I make I click a button, if I keep checking how many buttons are disabled, that gives me a way to sort of figure out, if the game is over or not. So that's what we're going to do. I get to my code over here. I define a new function. So I just function. So I get back to my code. I define a new function called, say, check winner. Doesn't take any arguments. And I just want to basically count how many how many squares are disabled. For that purpose, I keep a variable called count. I set it to 0. I just look through all the, let's say, all the squares on the board. So I basically run a loop of, let's say, this sort. So just, in fact, I can just get this. So I just go and say, look, if, so for example, for KK, in range n rows, and say JJ in rows n calls, if, let's say, buttons, say KK, JJ, if the state of that button is, let's say, disabled, right? So exactly what we were doing, for example, um, over here, so when we are trying to say, okay, look, if the button is disabled, I won't continue with the recursion. Same thing I'm doing. I'm saying, look, if the button is disabled, so let me just put a single quote for consistency. So I just go and say button state is, let's say, disabled. Then, I'm just going to count, say, count equals to count. I can just put count plus equals to 1. So basically, it's counting how many buttons are disabled in the entire field. And if I find that the count is equal to, let's say, n rows times say n calls minus n mines. So essentially I'm saying that, look, n mines must not be disabled because those are the actual mines. But if this number is reaching n calls times n rows minus n mines, then I can return a true. So, that's pretty much all I need to do. So let me just put a small comment over here. Count the number of disabled say squares or buttons and determine if the game is over. Now where should I call this function? Very clearly, this must be called from inside the onClick, because all of this happens only after the player has, let's say, made a click. In fact, what I will do is that I will let the if elif else run its course, which means it could be one of those cells which is being opened up, it could be a mine, it could be whatever. At the end of all that, I just go and check, look, if I have a winner. So I just go and say, if, let's say, check, say check, say winner. I hope I've got this, the, yeah, so that sounds correct. If check winner, remember that returns me a true or a false. If this happens, now what do? I print, for example, let's say player, say 1. Now, having done this, I want to make sure that all the mines are now displayed. How do I know what are the mines? Well, all I need to do is to look back at my list locations. In fact, that is what we were doing. Let's say, you know, in fact, that is exactly what we were doing when we were updating the field list. So I will just get basically, let's say, this structure in place. Actually, let me get this entire thing so that I can do a little bit of copy and paste and get my mines to be visible. So let me just get back here. So I say player is 1. I then go to all the mines, because remember, if in this situation the mines are not, let's say, revealed, mines box is still there. So I will go to once again my, let's say, lock xy for a mine. Instead of looking at field, in fact, what I'll do is to say buttons, let's say lock xy 0, lock xy 1. I will disable them first. So I'll just go and say state is equal to, say, disabled. Makes a lot of sense here. And once it is disabled, so I'm just going to copy this a little bit. Have to be a little bit careful, otherwise very easy to make mistakes. Dot, let's say relief is, say, for example, dot, say config, and relief is equal to, say, tk dot, say sunken, say tk dot sunken. And I want to now do something which I was, so let me just copy this again. So I want to now, let's say, dot, say, so here, again, a little bit painful. So I just want to set the text to be, again, let's say an asterisk. However, now I will set the background to, let's say, so let me get this statement over here. Okay, so I just copy paste a little bit over here. So I will just set this color to, so obviously I have to be a little bit careful here. I will set for these locations. So, the lock XY. So basically this is going on all the mines locations, and lock XY1. This time round, the background, I would want to set it to, let's say, green, so that it kind of, gives a green signal that you have won, and the foreground can be. So that's the whole idea. Basically, on the check winner function, I first count how many how many squares are still disabled. Oh, I see a problem here. So it should be double, let's say, disabled. So when I run this piece of code, basically, let me start with my regular strategy to say, okay, let me just try my luck at the corner. All right, so there's one mine over here. This corner, there are two mines. I want something to open up a little bit. All right, so this was cool. A lot of things opened up. This must be helpful. So I know here's a mine. I know that there are two mines in here. This is a mine. This is a mine. This is a mine. This must not be a mine. This must not be a mine either. Okay, so if that is the case, well, look at, so this is, okay, so I know this, there are two over here. This is a mine, this is a mine, so this must not be a mine. If this is not a mine, then this is not a mine, this is not a mine. Okay, so if that is the case, there are, again, let's say this is sorted out. Now I've got two over here. Okay, let me just try to sort of, let's say, now this two, one of these two has to be a mine. Question is which one? So it could be this, it could be that. Okay, never mind. Let's just try to say, okay, click it here. Okay, so this is helpful. Things open up quite a bit. So here's a mine. So this one is, well, for sure a mine. In fact, if this is a mine, then, well, doesn't really help me either. Oh, this is so hard. Okay, so this is nice. So I've got four around the square. So that means these four are mines. I can comfortably click on this. If these four are mines, these two is done. This is not a mine. This is not a mine. And hence this here must be a mine. So I'm not going to touch it. This is not a mine. This is not a mine. And notice what happened. The moment I clicked that, it turned out that look, I won and everything became here. I mean, all the mines here became green, giving me a nice, good feeling about my game, and also in the process completing my entire project. As always, this has been a long systematic journey where we have analyzed every part of the code carefully. The game itself is very, very interesting. The way we lay out the two dimensions, the way we set up the field list, way we compute the neighbors, and then how we do, let's say, the recursion. Very, very interesting in my opinion. And and as always, there's room as always, there is room to expand this activity. For example, we can make the field flexible. You can give the user a choice. Okay, how many mines do you want? How many, let's say, rows and columns you want? In fact, the code is already quite flexible, so you can do that, quite comfortably. You can build the flagging feature. Basically, say that, okay, look, I mean, I think there may be a mine here that really helps when you are, playing the game, because then you don't have to keep counting how many mines there are. And for that matter, you can keep telling how many, let's say, mines have been flagged. You can add more widgets, so how much time is taken. You can have some kind of a start button which clears up the game again once you click it. Like I said, you can indicate how many squares have been and then there are a bunch of Minesweeper variants that you can look at. Consider building them. But remember, always bonus comes after basic. The game that we developed is fairly involved code, I would say. So go through it slowly, try to understand the main concepts, and you will find that once you get the hang of it, then obviously this can be extended. Or on that note, I hope you found this entire journey of building Minesweeper interesting, engaging, and thought provoking. At Ybyte, we learn Python programming by getting deep into code, trying to understand how things work, and try to build an intuition around them. Look at our website www.ybyte.in because we learn Python programming through fun activities like the one we just finished. Take care. Thank you so much. Enjoy programming.